We would like to build a simple network, calibrate it with PEMS loop detector data, and run a simple forward simulation. Let's make a simple freeway model in Pasadena. We'll do it between Lake and Hill Avenues on the 210. So I need to define my links and nodes. Let's call this a 5-lane freeway. I need to split it at the merges and diverges. Here's for our on-ramp, and for the off-ramp, add the on-ramp, add link to this node. Let's change its type, the type of the link, to on-ramp. And we'll do similarly for the off-ramp. And let's make these 1 lane for the ramps. 1 lane. Okay, so we have a very simple network for starters. Let's save this to the database. So this scenario called simple demonstration. And we're going to save a new VIA scenario. And let's take a look. Pull it back from the database. Here's our simple demonstration, 488. Okay. Now what we'd like to do is to pull in some PEMS loop detectors to associate with our network. Whoops, that was very much the wrong thing to click. Okay. Import PEMS VDS stations. I know there happen to be some in this neighborhood here. Okay, so we actually brought in 3 VDSs. We have an on-ramp VDS here. We're not interested in that one for this demonstration. This is the HOV detector at this location. We're just going to concern ourselves with the main line. So I'm going to associate these. We can save my work, save via scenario. Here's our sensor set saved. I just want to make some demands, some input flows into these networks. We're just going to do some simple constant demands. It'll just be constant all day long. Here we are for the main line. We'll do it for the general vehicle type. And we're just going to do half a vehicle per second. So that's 1 vehicle every 2 seconds. On the ramp, let's go a little crazy on the ramp. On the ramp, we are going to do a similar thing, but with a very different value. We are going to add 2 vehicles per second. This is really an unrealistic demand, but it will certainly show itself in our model when we run it. Let's save the work of the demands. Saving demand set. And let's also make a split ratio at this diverge. So what we'll do is we'll make it constant through the whole day for all vehicle types. And we have the output link ID on the main line is ID 4, the ramp is ID 5. So on the main line, let's have 90% of traffic continue on the main line. And for the off-ramp, let's have 10% of the flow exit at this location. Let's save this as well. Okay, now we're ready to run some calibration on this scenario number 488. So we'll enter that into the calibration tool. Let's just use about 10 days of data We typically use more, but this will run more quickly. So the data is being read, and the statistics will be run to create a simple fundamental diagram. Now on the main line, the upstream link, which has the sensor associated with it, will receive the fundamental diagram based on that sensor's data, and that will be propagated down the main line through all the downstream links. The ramps will get typical values rather than sensor calibrated values. So we can take a look at the results of this, now complete. We can open it back from the database, because now it's been improved with some fundamental diagram calibration. Here's our simple demonstration. Take a look. You can see here on this mainline link, it now has a diagram profile. You can see, for example, 25 meters per second free flow speed and other associated parameters. And if we take a look at this mainline or this off ramp, we can see it too has a fundamental diagram profile. It has some typical values. The ramps we did not have inherit from the mainline. Okay, we're now ready to run a simulation on our scenario 488. This is the simulation tool. Scenario 488. Simple demonstration. We'll just have it run for 1 hour, or just about an hour of simulation time. And we'll run the job. This is being loaded. Okay, so the model is now running through the simulation time and recording its output to the database, and it's complete. So now we can view the results. I'm going to reload the viewer because it needs to learn of the new simulation run. Here it is. There's my scenario 488. I'm going to zoom in on the map here to see lake and hill. 210. And let's load some data. Take a moment. There we go. So you can see, for example, here on the main line, we can see the densities and speeds. The ramp, the speed is effectively 0 because I've flooded it with an unrealistic amount of vehicles. You can also look at where we have this diverge. You can see 0.038 or about 0.04 vehicles per meter. And we can see about 1/10 of that on the off-ramp. That corresponds to our split ratio. And that completes our demonstration.